Welcome. Today we are going to learn another problem on how to form the PDE by eliminating arbitrary constants. Here is the question. Now we take this equation as equation 1. Now we are going to partial differentiate this equation 1 with respect to x and y. First we are going to partial differentiate with respect to x. So p equal to, here p is nothing but dz by dx. We can write this partial differentiating, this will get a as it is and n x power n minus 1 plus 0, as it is totally a constant without any x terms, so it becomes 0. Now p equal to an x power n minus 1. Now in the same way we are going to partial differentiate with respect to y. So let's take another term as q equal to dz by dy equal to, first term becomes 0 as it is without any y term, so 0 plus b as it is and n y power n minus 1, so q becomes bn y power n minus 1. So take this as equation 2 and take this as equation 3. And keep the a term in one side and move the other terms to other side, so it becomes a equal to p by nx power n minus 1, and same way we are going to do here. So b equal to q by n y power n minus 1. So keep this equation 4 and this as equation 5. Now we are going to substitute equation 4 and equation 5 in the first equation. So it becomes p equal to z equal to p by nx power n minus 1 into x power n, here this x power n, plus b is q by n y power n minus 1 and this y power n. Now we are going to separate these terms. X power n minus 1, we can write it as x power n into x power minus 1 and x power n plus we are going to write this also like this. So q by n y power n y power minus 1 into y power n. We cancel these terms. In x power minus 1 and y power minus 1 will go to numerator. Px by n plus qy by n. N is a common term, so write it as px plus qy by n. N, move this n to left side, so it becomes Zn equal to px plus qy, which is the required PDE.